morning. Today is Wednesday, May 20th. Let's begin with some science. So today we're going to be doing our electricity notes, which should be the next page in our Ultimate Science notebook. I'm going to go through this with you. I'm also going to teach you the song that goes with it, just because it's great to have in your back pocket. And when you get to 6th grade, you're going to be like, I'm so glad I listened to Mrs. Benavides, even though it was cheesy when I was watching the video. That's what I'm hoping. So remember, going back for a second, this is an introduction to electricity. Electricity is actually very complicated. We're going to do the best we can. I'm not sure how much experience you guys have had with electricity in the past, so this might be a little bit much right now. Just kind of keep in mind that all things we know about the universe can be divided into two major categories, right? Matter and energy. Energy can be potential or kinetic. And then that potential and kinetic energy is divided further into many different categories. We have mechanical, sound, light, heat, thermal, and that's kind of how they can all be divided out. So let's kind of go from here, filling in our notes and then doing the interactive notebook. So for our notes, what is electricity? Electricity is the flow of electrons. And just kind of reviewing again, protons are positive, neutrons are neutral, electrons are negative, and float around the nucleus. We say there are two main types of energy. They are potential, kinetic. And then if we review our types of energy, we have 1, 2, 3. Mechanical is energy of movement. Electrical is the flow of electrons. Chemical is in food and batteries too, stored in chemical bonds. Sound needs matter with vibrations. Thermal is heat like the sun in the sky. Radiant is light that travels in transverse waves, bouncing to our eyes. So, I'm always out of breath by the end of that song because it's like no room to breathe. So electricity, if we're looking at this girl who has a circuit in front of her, she has electricity or flowing electrons through that circuit. So we can simplify how electricity is made into the turning of turbines. So in Colorado, we have a lot of windmills. They turn the turbine, and that turbine then is able to pull those electrons essentially away from the rest of the atom. To create electricity, we use fossil fuels, wind, water, and other renewable resources to turn turbines and power our homes. Conductors are materials that easily allow the flow of heat and electricity. So conductors are usually metal. So that's an example like the key, the penny, the wire. So if I have a circuit in front of me, I need something metal to connect it. This is kind of best seen if you ever have seen like dead Christmas trees, tree lights. If you cut through it, that wire is what's allowing that electricity. Obviously, if it's already dead, you have permission and it's unplugged from the wall. But if you were to open up those Christmas tree lights, you could see the wire inside. That's how that electricity is hitting all those different light bulbs on that path. Insulators are materials that stop the flow of electricity. So these are things like rubber, wood, and cork that if we put them in the way, they will not allow the flow of electricity. So resistors resist or slow the flow of electrons. Examples include fans, light bulbs, and other devices that use electricity. So let's kind of go through that again. Electricity is the flow of electrons. We can simplify it to the turning of turbines like a windmill. Conductors is stuff that allows electricity. Insulators are stuff that don't allow electricity to pass through, or energy in general. Resistors are things that use electricity to work, like fans and light bulbs and radios. So how do we have electricity flowing? So we always need a complete circular path. So if we were in our classroom, and I'm going to try to do this here, I would say, and I'm going to pause for a second to get myself set up. Okay, so we were in our classroom, I'd have us all sitting here, and I'd be running around in a circle and showing you that I'm a little electron, and I'm running around, and I have a complete path to flow on. If I have this suitcase in my way, that's like an insulator. This path is my circuit. The conductors allow me to travel on that circuit. If I'm running, oh no, I can't move anymore. This is an insulator. If I have something, and if we were doing this in the classroom, I'd have one of you to high five me. I'm going to use this Seawald whale. It's slowing me down because I have to high five it, but that's what using electricity. So in this analogy, I'm the little electron. I'm using the electricity. I'm traveling down my path. So series is when it only has one path. If I had more than one path to travel on, that would be parallel. Just like parallel lines. So this is what a series path looks like. One path, so it can have more than one light bulb on it, but it only has one path for it to flow on. A parallel circuit, now you can see, is a more complex kind of circuit, more than one path for electrons to flow on. And this is going to be important because in a series circuit, if there is a suitcase or an insulator blocking the flow from that negative part of my battery to the positive part, if there's something blocking it, then both of those light bulbs are going to go out. For my parallel circuit, if there's a blockage, I might still be able to hit one of those light bulbs. Okay, so that's kind of the notes. Let's do the song. I'm ready. This is an intense one. So this song starts off with electrons flowing past. So this is an old song from, I think, my hometown. And it is Don't Stop Believin'. So if you know that song, you're in great shape. So it goes. Because remember, this is electrons flowing, right? Electrons flowing past. Series has one single path. So remember, series is like when I have my battery here, which this is how I'd represent that battery, plus and minus, right? Has one path. So electrons flowing past. Let's pretend this is how I represent a resistor. I don't know, electrical diagram. Electrons flowing past. Series has one single path. Now if I add another line, I can even add another resistor. Parallel has two different ways to keep the light. Okay, so that's because, let's say there's a little break, a little insulator, like air, in between here and here. In a series circuit, if this isn't here, I'm stopped. This light bulb's going to go out. If I have a parallel circuit, I'm not going to be able to go down to this light bulb still, but I have another way to go around and around and around. That's why in your house, if one light bulb goes out, all the light bulbs don't go out, because now in modern houses, we have almost all parallel. So, whoops. So we go. 1, 2, 2.5, 3. Electrons flowing past. Series has one single path. Parallel has two different ways to keep the light. Okay. Series electrons. Oh yeah. So then we go back to here. Series electrons flowing about. One resistor goes, the rest go out. And that's kind of what I was just talking about, right? If one resistor goes, the rest are going to go. One resistor goes, the rest go out. Parallel has two different ways to keep them bright. So let's do that from the beginning. 1, 2, 2.5, 3. Electrons flowing past. Series has one single path. Parallel has two different ways to keep them bright. The light. Series electrons flowing about. One resistor goes, the rest go out. Parallels has two different ways to keep them bright. Then we go. Circuits can be open and closed. Circuits can be open, they can be closed. So an open circuit is one like this that isn't complete. It has something in the way that's stopping the electrons from going all the way around. A closed circuit is one that allows the electrons to go around. Now let's think, what do we have in our houses that turns on and off lights that might open and close our circuits? What's that called? A switch. That's exactly what it's called here in our diagram. So if I see a switch that's like this, okay, this is open. That means the lights are off, or at least this one is. If I see a switch like this, that means that my lights are closed. that my switch is closed in essence, so that both lights will be on. So it goes. Let's start from the beginning. 1, 2, 2.5, 3. Electrons flowing past. Series has one single path. Parallel has two different ways to keep the light. Series electrons flowing about. One resistor goes, the rest go out. Parallel has two different ways to keep them bright. Circuits can be open and closed. Switches make it stop and go. Resistors use electricity like fans and lights and radios. So in class we would spin around because it's like a fan, right? And a fan is an example of a resistor or something that uses electricity. Just to review before we move on. This is my battery or my power source. This is what the closed switch looks like. The open switch is kind of off to an angle. This is what a resistor looks like in a circuit, aka things that use electricity like this light bulb or a radio or a fan or anything that you plug into an outlet. So now we have conductors allow electricity to flow like water easily. So in this diagram, conductors are the wires, right? That are allowing my electrons to flow on a path from negative to positive. So conductors allow electricity to flow like water easily. Conductors made of metal like wire. I forget what the wire thing was. I think we went like this to connect it, like this. So let's start from the beginning. 1, 2, 2.5, 3. Electrons flowing past. Series has one single path. Parallel has two different ways to keep the light. Series electrons flowing about. One resistor goes, the rest go out. Parallel has two different ways to keep them bright. Circuits can be open and closed. Switches make it stop and go. Resistors use electricity like fans, lights, and radios. Conductors allow electricity to flow like water easily. Conductors made of metal like wire. Insulators block electricity. Hang on. Okay, so we go like this because insulators, they block electricity. So air, for example, is an insulator because obviously there's not electricity flowing through the air right now. That would be a huge problem. But this is also things like wood, styrofoam, anything like that that blocks electricity. So let's say I put a big piece of rubber right here. This is my insulator. It's going to turn off all my light bulbs. So insulators block electricity. Plastic would no energy. Insulators like rubber on a tire. So that's the whole electricity song. Hopefully you enjoyed it, along with our review of the energy song. I think these are the longest songs, but they're also the most useful as you go off into 6th grade. So make sure you memorize them if you're able. Our interactive notebook for today, you are sorting these based on whether they are conductor or insulator. So you're going to need to cut out, all of those images on the right and sort them. So pause this video, only come back when you're ready for the answers, and I will happily give them to you now. So wire is a conductor. Paperclip is a conductor. Cork, not a corpse. Cork is an insulator. Water is surprisingly a conductor. Think about it. If it's lightning outside, you can't go swimming because the electricity will electrocute you in the pool. Rubber is an insulator. A metal key, metal is a conductor. Paper coffee cup is an insulator. Copper is a conductor. The paper coffee cup is an insulator because you don't want that heat from the coffee or your chai tea latte, if you're me or Riley, to get to your hand. Wood is an insulator, and plastic metal covering. Plastic wood, no energy. It's an insulator. Awesome. Thank you so much for joining me today, everybody. I miss you guys so much. I wish I was singing with you in class. and I'm sending you all my love. I will see you in the afternoon. Bye.